Hello everyone. Welcome to the solution of LeetCode problem 22 named generate parenthesis. In this problem, given n pair of parentheses and we have to write a function to generate all combination of well-formed parentheses. Suppose here, if the value of n is 3, there are 5 possible well-formed parentheses. And if the value of n is 1, so there are 1 possible well-formed parentheses. Now the constraint are the value of n can be in between 1 to 8. I hope you understood the problem statement. Now let's move on to the algorithm. Now, before jumping into the solution, let us try to understand what is basically the well-formed parenthesis. Now, well-formed parenthesis is for every open brackets, we have the corresponding closing brackets after the open brackets. Now, we can start the combination by using the open bracket. It is possible, but we cannot start the combination by using the closing bracket, because if the first symbol is the closing bracket, then afterwards what we do next, it will always become invalid. But if the first position or the first character is the opening bracket, then it is possible for our bracket sequence to become valid. Now, so far so good. So let's break down the problem. Now our problem is, how can we add the open bracket and how can we add the closing bracket? So here, in the problem statement, we are given a limit, which is n. Suppose n is 3. Okay. Now, we can add at most 3 open brackets in our given combinations, right? So here, for adding the open bracket, the condition is open, or the number of open brackets should be less than n. So this is the first condition. That means if the value of the open bracket is 3, that means we cannot add 4 open bracket, right? One more thing, here the value of n is 3. That means in our bracket sequence, all of the bracket sequence will have 6 character, 3 open brackets and 3 closing one. Now, this is the one condition. Here we can add as many number open brackets such that until the frequency of open bracket is less than n. Now we have to determine what is the condition of the using the closing bracket. This is little bit of tricky. Suppose this is one of the sequence, open bracket, closing bracket. Okay. Now here, if we add another closing bracket, the corresponding sequence will still be valid. So far, so good. So here, before adding a closing bracket, we have to always determine, is there any sufficient amount of open bracket present before it or not. Suppose the open bracket is 1, or we have 1 open bracket. Now we have another closing bracket. Now for these positions, we cannot add any of the closing bracket, right? Because for this closing bracket, it does not have sufficient corresponding open bracket here. So here, to add the closing bracket, the condition will be the frequency of closing bracket should be less than the frequency of open bracket. If this condition is valid, we can add the closing bracket. And if this first condition is valid, we can add the opening bracket. Now, we have determined 2 of the conditions of adding the opening and closing brackets. Now, let us see how can we solve this problem by using the backtracking solution. Suppose we have at the first state here. Now here, we have only one choice because we can only add the opening bracket. here we cannot add any of the closing bracket, because if we add any of the closing bracket, the sequence will start with the closing bracket and it will be invalid. So here it is the main criteria for this first iteration to start the sequence with the opening bracket. Okay, so far so good. Now for this opening bracket, we have two choices. Either I can add one of the opening bracket here, either I can add one of the closing bracket here. Now here I can able be add one of the opening bracket because the value of n is 3. So here the opening bracket is 2, so it is possible. And we can also add one of the closing bracket here. Okay, so far so good. Now for this two opening bracket, we have two choices. Either I can add another opening bracket here, or I can add one of the closing bracket here. Here we have used 3 of the opening brackets. Okay, now for this opening and closing brackets, we have one choice. Here we can only add one of the opening bracket. Here we cannot add any of the closing bracket because this will become the sequence invalid. Okay. Now for these 3 opening brackets, we have one choice. We can add one of the closing bracket here. Here we cannot add any opening brackets because the frequency of opening brackets is 3 already. So if we add another opening bracket here, it will become out of limits. So here it is not possible. Now for this opening and closing brackets, we have two choice. Either I can add one of the opening bracket here, or either I can add one of the closing bracket here. So far so good. Now for this open, closing and open bracket sequence, we have two choice. Either I can add one of the opening bracket, closing bracket, then either I can add one of the opening bracket here, or I can add one of the closing bracket here. Okay. Now for this, we have one choice because we have used 3 of the opening brackets. So that's why we have to use another closing bracket here. Now for this, we have one choice because we have used 3 of the opening brackets. So we have to use the closing brackets here. Now for this, we have only one choice because we can only add opening bracket here. Now for this, we have one choice because we can add only closing bracket here because we have used all of the opening brackets. Now for this, we only have one choice. We can add the opening bracket here. Okay. Now, finally, for this, we have to add the closing brackets because we have used all of the opening sequence. Now, for this, we have to add closing brackets because we have used all of the opening brackets here. And for this, we have to add a closing bracket. For this, we have to add another closing bracket. And for this, we have to add another closing bracket. Okay, so far so good. So here we can see that there are 5 possible combination we have found. Here, this is the base case because in each of the combination, the frequency of the opening bracket is 3 and the frequency of the closing bracket is 3. So here, when the frequency of opening and closing bracket is equal to n, we have to simply return from this iteration. I hope you understood the backtracking algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named generate parenthesis, which has an input n as a parameter. Now, we are using a vector of string to store the answer. Now, we are calling a backtracking function. The first parameter is the default string, which is empty string. The second is the initial frequency of opening brackets, and the third one is the initial frequency of the closing brackets. Both of them are 0. And the fourth one is the value n, and the fifth one is the resulting answer. Now, in the backtracking function, we have to check the base condition at first. So here the base condition is if the open and the close is equal to n, we have to simply push the current state of string into the answer and simply return it. Otherwise, if the number of open is less than n, that means here we can add one of the open parentheses and increase the frequency of open here. And here, if the frequency of close is less than open, here we can add a closing parenthesis and increase the frequency of close. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.